Okay, go ahead. Questions? List. Hash table, just hash table, right? We don't need a two-dimensional array. It's only for your self-study during the summer. So two-dimensional array is not covered in the exam. But for hash table, which part specifically, or you want me to go from scratch? General idea. Okay. For hash table, I think, let me just bring up another diagram over here quickly. Okay. Bear with me. Okay, about hash table. Okay, let me just briefly walk through what I said on Wednesday just quickly. We can think about hash table just like a two-column table. Okay, two columns. Okay, again, you got keys and you got values. And also for the keys, most importantly, there will be no duplicates. For example, you got Alan, you got Mark, and you got Tom. The reason that you should not have any duplicate is because every time given a key, you want to uniquely identify a particular row. For that row, you can either delete it or you can try to get the value for that. Okay, let me just review quickly the syntax. When you go over the slides, I also posted the Java code for you. For the exam, you are not expected to write Java code for hash table. You are expected to read it. Okay? Let me just show you the critical methods quickly. So now, first of all, whenever you see, for example, you see the new keyword over here. Okay? Let me just make it smaller. If you see the new keyword here, that means you're creating a new object. In this case, we have the variable name called grades. We're creating a variable just called grades. What's the type? It's simply just a hash table. So now, all you have to know about declaring the hash table is as follows. You have to give two types. Okay? The first type is a string, and this type over here is for the keys. Okay? This one is for the keys. And the second one over here is for the values. Let's do another example quickly. Remember the optional lab number 7. We talked about a birthday book application, right? In that case, we can declare the hash table in a slightly different way. I'll write it down here. You can simply say hash table over here, and then you can give two types over here. Okay, I'll put it down in just a moment. Let's say I can simply say book. Okay, it's assigned to some new hash table, etc. So now for the keys and values, so this will be the keys and this will be the values. In the case of the birthday book, basically you want to make sure all the names of the user are unique. There's no duplicate for the username, and that pretty much corresponds to reality. So now in that case, you can simply put a string, in which case it's simply just name. And what about the value? Basically, this, in lab number 7, we simply create a new class called birthday, right? In that case, you can simply put birthday over here as the value type. Okay, just another example. So you are not really bounded to what kind of types you can put as key and value. You're really up to what you need for your application. Okay. Let me just highlight a few more methods over here. So that's something you're supposed to know for the exam. First of all, you should know how to calculate the size depending on how many rows you have. Let's say for this particular table, you got 1 row, 2 rows, and 3 rows. So that'd be size 3. And also, you want to know if a particular key is in the table, right? In that case, Alan is indeed in the table, so that'll be true, right? And also, you can want to know if a particular value is in the table. In this case, is B plus in the table? It's a value. Look at the second column, it is there, okay? How do you update the table? You can either insert or delete. Let's see one example for insert. So you got your context object over here, grades, and then you say put. So now it's very straightforward because each row has 2 values, has 2 records over there, the key and the value. If you want to put, you will simply say Alan as a key and also A. So that's exactly how we created this particular row, Alan and A. So follow this order, key followed by the value. On the other hand, you want to be very careful with this particular one here. We are still calling the put. However, you can see that, let me just do one more, okay? if you look at this line here, we say grades.put, and then we say mark and then B+, right? So that will correspond to exactly this line over here, okay, mark and B+. But now later on, we try to do another put over here. We say grades.put. Now mark corresponds to some previous key that we already inserted, right? And also we want to overwrite his grade. In that case, you have to go to this particular row that's identified by mark and then change the letter grade to F. Okay, that's something you have to be careful about. So the best way for you to really keep track of is by drawing some diagram. Okay, that's about the, one more. What about removal? So whenever you want to remove, if I want to remove a particular row, I just need to give the key because every key can uniquely identify a particular row. That's why I just need to give the key. So if I say grades.remove Alan, I want to remove the row where the key is Alan. Okay? In that case, I will simply remove, like I just wipe it out, like that. Okay? So that's deleted. Yes? So, okay, let me just make it clearer. You know, at a runtime, it's never possible for you to get duplicate rows. Never possible, because, let me show you more explicitly again. Let's say we already got this particular table. Let me just draw again. Let me draw from scratch quickly. Let's say initially the table is simply just empty, let's say. Okay, initially the table is simply empty. And then, let's say I try the first one. If I say grades.put, and then I say Alan, and then let's say B, for example, right? If I do that, it's going to add this particular row, and then it's going to put Alan as the key, and also B as a letter grade. Okay, so far there's no duplicates. You were asking what if we got duplicate of keys. It's never going to be possible because, let's say, how would you insert something that's duplicates? You will simply use the same context object over here that put. Let's say I want to insert maybe just Alan again, right? If you try to do that over here, and also B, let's say C, for example, or B, doesn't matter, B or C. If you do this, it's not going to just create another row. That might be what you're thinking. No, it's not. It's not the case. What it will do instead, it is simply just going to say, well, because Alan already exists over here, I'm just going to change his existing grade to C. So duplicate is simply just not possible. Okay. Any more question about Hashtable? Okay. That's all you need to know about Hashtable, right? As I said, for those of you who might take a little bit more programming course or you want to self-study, you can explore more about Hashtable. But for this course, just introduction. Okay. Okay. Just throw me questions. Sure. Question 6. Okay. Yeah, let me just go to that question there. Okay. Lectures 1021, and then oh, sorry, not this one here. Number 6. Okay, number 6. Have you guys tried? Okay, let me, for those of you who are already here, right, I can tell you that on Sunday, my best advice, be patient. You got lots of questions during the exam. So don't think you can just walk out within 1 hour. You might have to spend at least 2 hours on the questions. Okay, just be patient, okay? But let's say you are facing this question here. How would you do it, okay? The best way to trace it would be draw a diagram. Okay, if you haven't done this yet, we can do it together. So I would say, well, let's draw line by line. We assume that we got a person class, and then each person has name and also just name. And also we have a constructor that's going to create the person with some initial name. Let's try that quickly, okay? Line number 1, what's going to happen if I say this, right? Okay, I'm going to draw on the iPad. Okay, you can bring out a piece of paper and then try. Basically, I have a new person with the name Hyun over here, and then P1. So what's going to happen is, P1, after that, is going to point to a new person object over here, and we assume every person has the attribute name. And then we're simply just going to put Hyun over here. Okay, very easy. Okay. Again, how the rectangle should look like depends on what attributes you have for the corresponding class, right? It's a very important technique for you to grasp. Okay, what about line number 2? Similarly, so now you have to ask yourself right away, for this particular line, should I draw a new box or should I simply change the arrow around? Very easy for you to judge because you see the new keyword over here, so you have to draw a new box. Okay? So what I will do is I'll create a new person, Jiyun. Okay? Okay, I'll simply put P2, let me just use a different color. Okay, P2 is pointing to another person object with the same structure. Okay, with a name. And in this case, it's going to be Jiyun. Okay, good. So now let's go back here. So now here comes the interesting bit. Okay, so now how do we visualize this? We did talk about this during the class, but let's review quickly. I'll write a line over on the iPad. So we are basically declaring like this. Okay, let me write it down. So we are basically saying person array, and then we'll say persons, P1, P2. Okay. Okay, just quickly review. So this notation over here, curly brackets, is called the array initializer. Okay. Basically, we're trying to create an array as we declare it. Okay. So now it might be easier for you if I try to rewrite this as follows. Okay. I'm gonna write it in pink. You're basically trying to declare this particular array. And now, how many elements do we want to initialize? 2, P1 and P2, right? I can simply say it's going to be a new person array with size 2, okay? Simply because I got P1 and P2. And now, how exactly do I initialize the contents? I can say persons in the order. P1 is going to be at index 0. P2 is going to be index 1. So persons at index 0 is assigned to P1. And then persons at position 1 is assigned to P2. So the orange and the pink, they're completely equivalent. You can think about having the orange line, just one line, is equivalent to doing 3 lines at one go. They're the same. Okay? You're simply saying creating a new array of size 2. The first index 0 should store P1, and index 1 should store P2. Okay? Let's now look at just one of them. If you look at this line over here, so what does that really mean? That means if you think about just a single assignment, you're basically trying to store whatever value that is stored in P1 into index 0 for this particular array, right? Let's draw that array quickly. Okay. So now persons is going to be an array. So persons over here is simply just going to be an array of size 2. Okay, so I'll draw size 2 over here. Okay, index 0, index 1. So now I'm saying that at index 0, which is over here, I would like to store whatever that is stored in P1. What have we stored in P1? If you look at P1, as we talk about, if the variable is of reference type, you only store the address of the objects, right? Now in this case, P1 basically stores the address of this particular objects. Okay? And now you want to store the same address into this particular slot. How do we draw that, right? You're basically saying, okay. So over here, you simply say store the address in P1 into index 0 of persons. Okay, if you do that, that means now this particular slot is going to store the same address as this one. So that means they'll be pointing to the same objects over here. Okay, it's a very critical step over here. Are we okay with this? Okay? Yeah. The next one, if you look at the next one, let's say this. Persons1 at index 1 is going to store P2. That means persons1 is this particular index. It's going to store the same address as P2. P2 is currently pointing to here. That means we also want to make sure this is also pointing to the same objects. Okay, this is a picture we have. Okay, are we okay? Yeah, let me just try to be a little bit more explicit over here. Try to highlight this a little bit. You can think about this guy here. So what aliasing do we have? You can see this particular arrow and also this particular arrow, they point to the same objects, right? In that case, in the Eclipse or on the paper, if you try persons1, persons at position 1 equals P2, it's going to be true, right? Actually, one of the quiz questions you received the feedback about is about something like this. Okay? Okay, that's about the setup for this one here. Let me just try to highlight one more. Okay, for this one here, this particular arrow and this particular arrow, they're pointing to the same objects. Okay, that's kind of the diagram you have. So now let's continue with the question. We are not done yet. So now let's see this. Line number 4, we say P1 is assigned to P2. Okay, what does that mean? So now if I try P1 is assigned to P2, what does that really mean? Are we trying to store something in P1 into P2, or are we trying to store something in P2 into P1? P2 into P1, right? You're always trying to store the right-hand side into the left-hand side. The principle about assignment is always the same. Whatever that is stored in P2, store that into P1, okay? So that means you can see that P2 is going to change its value over here. And what should that be changed into? Oh, sorry, what am I talking about? Sorry, let me say it again. When I say P1 is assigned to P2, that means I'm trying to store the right-hand side into the left-hand side. Okay, it's always the case. Now, I'm going to store whatever that's stored in P2 into P1. P2 is currently pointing to this particular object. Now, I want to change P1, basically, right? So that means after this, I'm going to have P1 rather than pointing to over here. It's going to point to wherever P2 is pointing to, right? Like that. So after this, what we have is, we have this. So now we got another aliasing over here. You can see that after this particular assignment over here, P1 is assigned to P2. After this guy over here, what we have is, you can see persons1 equals P2. That remains to be true. And also persons1 equals P1. That also is true, right? Because they also point to the same objects, right? P1 and P2, and also persons1. They all point to the same objects. Okay, guys. Yeah, it's a very small room, right? So let's try. If you got any question, just interrupt me, right? It's completely your time, okay? Whatever question you ask, I will answer. Okay, so now if you try this, line number 5, that's the final thing you want to analyze, right? After all this setup. Let me finish this and I'll get back to you. Yeah. So you got persons0 equals P1, okay? So now I'll write it down. So what you get is persons0 equals P1. Let me just make sure I copy that correctly. Okay, equals P1. Okay, let's see this. Now, all you got to do is look at the diagram. Persons0 is this particular slot. It's pointing to this particular object, right? That's a green one. And then let me use another color. So now what about P1? P1 is actually now pointing to this particular object, which is a pink. They are different objects. So the answer should be false. Okay, that's how you figure. Does it help? Okay. In the exam, you basically got similar setup like this, some questions. But I would suggest, remember in the classes and objects lecture, there was one example about using loops, to actually assign one array to another one. Review that carefully. I did a slight change to that example in the exam. Slight change, okay? Yeah.
So I have a question. So the you said person 0 equals P1. If they wouldn't all update since P1's address like updated, P2,
yeah. Yeah, so basically thinking this way, every assignment is done independently. So when you were trying to do P1 is assigned to P2, for example, over here, right? When you were trying to do this, you're only changing one guy, which is P1. Whatever that's also pointing to the same object as P1 is doing, they won't be changed. It's independent.
Use a mutator with them.
Yeah, exactly. So now let's try go a little bit further. Okay. Okay, let me just try to give you another cleaner example, just simple. Okay, let's say this. Let's say we got P1 is pointing to some new person over here. Okay, let's say name. I'll just say, let's say Alan. Let's say we got another P2. And then person. Name. Let's say Mark. Okay, assuming that we already created these two person objects. Okay, so now let's try to see one thing here. If I simply say P1.setName, let's say we got this mutator. Let's say we want to change the name for P1. Let's say we want to change that to Tom. What's going to happen here? Well, because the context object is P1, we're only going to modify this object here, right? So that means we're only going to change that to Tom. You can see at the same time, whatever that's being pointed to by P2, they are not affected. Okay, number one. Okay, let me do another one. If I say after this, I would say P2 is assigned to P1. Okay, if I say P2 is assigned to P1, that means I'm changing P2. That means the arrow for P2 should change. What should that change into? It's going to change to whatever P1 is pointing to, right? So now that means P2, rather than pointing to over here, is now going to point to the same object as P1. So after this, we got aliasing. Because if you try to do P1 equals P2, it's simply just going to be true. Okay, let's do one more. If you do exactly the line we just did, exactly the same line. If I say P1.setName, let's say I want to set the name to be Simon, for example. Think about what's happening over here. Even though I'm using P1 to set a name, so that means whatever object that's being pointed to by P1, at the same time, is also being pointed to by P2, right? Even though I'm using P1 only to set it. So that means after this, I'm going to change from Tom into Simon. You can see after this, if I try P2.getName, it's going to be Simon. Because P2 is now pointing to the same object that's being changed. That's aliasing. Aliasing simply means if there are multiple variables storing the address of the same objects, it doesn't matter which variable you use to modify the objects. As soon as the object is modified, it's going to be visible to all the other variables. Okay, that's something to keep in mind. Okay, that will simply just be Simon. Okay, questions? Yeah. Which one? Question 8. Okay. If I go to question 8. Okay, question 8 will be similar, right? Okay, how about this? Let me try to be a little bit more efficient over here. For question number 8, yeah? Oh no, I'll answer the question first and I'll come to yours, yeah. Okay, that's question number 8. Okay guys, we still have to keep it low, right? Yeah. Okay, how do we do this one here? Okay, let's do it quickly. Now, it's going to be very similar. You can see basically up to this point over here is pretty much the same as before. Let me draw that quickly. Okay, this line here, P1 is now going to point to a new person object over here where the name is simply here. Okay, line number 2 is going to be P2 pointing to this object over here, and then the name is going to be Jean. Okay, same as before, I'm just going to be faster. And then we're going to create an array. Okay, let's say we're going to create an array, let's say persons, which is going to point to 2 objects, so size 2. Index 0 should be pointing to P1. Index 1 should be pointing to whatever P2 is pointing to, right? Okay, let's do the rest. What about this line here? Line number 4. P1 is assigned to persons 1. First of all, which arrow are we changing? You can see how many arrows do we have? We have arrow number 1, arrow number 1, arrow number 2, arrow number 3, arrow number 4. Each of the arrows correspond to some address we are storing at the same at the moment. So now line number 4. Which arrow are we changing? 1? Agree? Yep. Because P1 is exactly left hand side. What should that be changed into? Persons 1. Persons 1 is over here, right? It's exactly this one here. So that means P1, rather than pointing to over here, is now going to point to wherever the orange one is going to point to. Okay, just like that. Okay, the principle, again, is easy. Think about which arrow should be changed, and what should that be changed into. Okay? Okay, that's about line number 4. And let's do more. What about line number 5 over here? Again, which arrow are we changing? 1, 2, 3, 4. 2? Agree? Yep. Because we're changing person 0 over here, right? Person 0 is exactly over here. Change that to wherever P2 is pointing to. So now rather than pointing to over here, it's now going to point to wherever P2 is pointing to, which means like this. Okay, so now let's do some mutator method call. Oh, actually after this, let's think about this. Let me ask you this. Aliasing. At the runtime, we still have only 2 objects. Let's call this orange objects. And let's say this is blue objects, orange and the blue. So now, question for you. Can you tell me all the variables or all the variables that's referring to the orange objects? Anything? Is there any variable at this point storing the address of the orange objects? Used to be P1 and also person 0 used to be, but both of them have been redirected elsewhere. Okay? So now, just for your knowledge, it's not on the exam. So now in this case, for this particular object, it's not being stored anywhere in the variable. It will be so-called garbage collected later. Okay? If you've heard about any term like a garbage collection, that's exactly a scenario. Okay? This will be garbage collected. Okay, let's now, what about the blue objects? Well, basically now every variable is pointing to the same blue objects, right? If you see P1 equal P1, also P2, and also persons at position 0, and also persons at position 1. If you try to check all the address stored in all these 4 variables, they are the same. Okay, let's do one more. What about we say P2.setName, Jihei, over here. And P2 is pointing to this particular blue object over here, and we are modifying the name to be Jihei over here. Okay, that's what we're doing. And now system.out.println P1.name. Right? What's P1 pointing to? The same object over here, so that should be Jihei. Okay? Okay, that's about like this one is a little bit more challenging than the previous one, but as long as you know how to draw the arrows around, it's not too bad. Still have questions?
So
Oh, you get lost. Okay, so the question was, at this point, is it still possible to get hold of the address for this orange box? No, because it's been lost. Yeah.
So, can we delete an address, or we just reassign values to it?
Can you say it again? I don't quite make sure I catch that. Yeah.
Can we delete an address?
Can you delete an address? No. No. In some way in Java, it's actually not very flexible. You can only create new objects, in which case you're being allocated a new address. For the new address, you can store that in any of the variable you like, but you cannot really delete the address. If you program in C, for example, you can freely allocate with the allocate memory, in which case, yes, you can, but not in Java. Yeah. Mm-hmm. Any more questions? Yes. Which one? Quiz number 5. You know what? I don't have access to the quizzes over here. Let me see what I can do. On your feedback, is there some question ID for your? Bring it to me quickly. Yeah, well, just I want to see which question it is. All right, thanks. The first one? The first and second. Okay, just repeat to me the ID. Okay, there's the ID over here. 114 first. Okay, 114. Okay, so now the quiz question over here. Okay. Okay, I'll try to make sure it's not exactly readable. Sorry, that's XML, but I'll try to help you understand what the question is about. So that's quiz number 5, one of the questions. Basically, we want to consider this block of code, okay, over here, okay, this block of code. Okay, I will try to repeat it in just a moment. So now the question, when running the above program, which of the following value will result in the following console output? Well, you know what? Let me do this. Okay, I think that will work. You sending it to me? Wow. Thanks. All right. Yep. 114. Which one is going to result in an array index out of bound exception, right? Okay. You know what? I still need to take a screenshot. Okay, this will be good. Okay, so now, is it readable, the code? Like that, okay? Okay, so for this fragment of code, basically you have some scanner in the first line, and then you have an array of size 2. You got -1, you got 2. Okay, you gotta keep reading some input value, okay? So now you have conjunction over here. Okay, I see what the point is about this question here. Something about short circuit. Okay, so now for short circuit question, you're always evaluating from left to right, right? Always from left to right, which means you're going to evaluate. Let me highlight this. There are three Boolean conditions over here. You got, let's say, the orange, and you got the blue, and also you have the green. So these are the three Boolean expressions you're going to evaluate at the runtime. The orange first. Now, if the orange one is already false, I don't bother to evaluate to the right, right? That's a short circuit, right? You only evaluate the blue if the orange is true, okay? You only evaluate the green if both the orange and blue are true, okay? That's kind of the principle, okay? So now the question is, what value is going to generate array index out of bound exception, okay? First of all, you know that you can only get array index out of bound exception if you got array indexing. It's right here, okay? I'll try to derive a little bit more question from this so you can learn from that. For this particular one, you can see we are going to evaluate orange right away. How can you get array index out of bound exception? Either when the index is too small or too large, right? What's considered as too small? -1 or -2, etc. 0 is the smallest index you can have, right? And also, what would be too large? What would be the largest index you can have? More in general, it should be the length -1, right? So now if you think about that, 0, 1, all the way to ns.length -1. So these are all the valid indices, right? So now in this case, 0 and 1 are okay because the size is simply 2. Okay, so now if you try to give -1, for example, are we going to get array index out of bound exception? Yes, because we are trying that right away. What about if you try 2 as well, right? Because 2 is not valid for this particular array, so that's also not good. Okay, so this is not the most exciting variance. You're lucky, you get an easier one. Okay, so let me modify this question just a little bit. Okay, I'll put it here. Let's consider the following. What if I say 0 less than or equal to I, and ns at position I, modulo 2 equals 1, and I less than ns dot length. Okay, length. Let me just put a color in. So this is still the green one, and the blue one has been swapped to the front. The orange one has been swapped to the middle. So now, is the runtime behavior going to be different? Well, it is, right? Yeah, good. How exactly? Yeah, exactly. So now you can think about, in this second version over here, this is considered better because now we do check to see if I is larger than or equal to 0. So now if I still pass -1, am I going to get array index out of bound exception? No, because if you try -1, put it wrong place. 0 less than or equal to -1 is going to be false. That means you stop right there. Okay? On the other hand, what if I still give 2? Am I going to get array index out of bound exception? Yes, because if I try 2 over here, 0 less than or equal to 2 is going to be true. That means I should still go ahead to evaluate the middle one. And 2 over here is going to create array index out of bound exception. Okay? So you got different variants. I believe there's one particular slide in the array. Please do check it in the loops lecture. I do talk about different possibility over there. So now, what would be the correct way of doing this to make sure when it's either too small or too large, you simply just don't get array index out of bound exception? What should we change? You want to suggest something? Let's say the same 3 Boolean expression. What should I only need to swap the order. The correct version would be, I simply got the blue one over here. The blue one, still keep it there. And also, I will first of all check the green one. Okay, over here. And then finally, I will actually do the orange one. Okay, that will be the correct order, which means you try to check all the validity about the indices before you try to do anything about indexing. Okay? Yeah. Yeah, it's good that you asked me, so we can review the short circuit a little bit. Actually, short circuit is a very interesting phenomenon in every programming language, so it's not just unique to Java. So if you program in other languages, you will see similar. Whenever they got any conjunction with disjunction, it's always the case. Okay. Any other questions? Okay. I would say for the quizzes, I did repeat some questions in the exam. So if you don't memorize, I changed the value a little bit. All right. I only changed the input value. So I would suggest it will be like a bonus to you. If you just review your quiz question to understand what's going on, you will get some few marks. Yeah. Okay. How many? Between 56 and 70. Okay, I don't want to say exactly, right? It doesn't really matter that much to you, right? But mostly multiple choice. Okay, as I said on Wednesday, mostly. There may be written question, or there may not be. I don't want to say for now, because I do want you to get prepared for written question in case there are any. If there's any written question, if there's any, it would be similar to lab test 2, similar, but not that difficult. If there's any written question like in lab test 2, remember you got 4 questions, right? And the first 2 are basically taken from your practice test. It will only be similar to that. It wouldn't be like the final 2 questions in your lab test 2. It's too much for the exam, right? Okay. Yes, I'll come to you. Yeah, I would say, well, are there any practice question for API? I would say as long as you understand what's going on for the 2 examples I talked about in the lecture, you'll be okay. Yeah. Mm-hmm. Okay, questions? Yeah.
When you say hypothetically if there is going to be a written part of the
The 2-dimensional array is not.
So test 2 you said, right?
Mm-hmm. Okay.
How would it be like format? Like what would you writing out the code?
Okay, one possible written question could be like this. One possible. Okay, let me say that precisely. Oh, guys, by the way, you received a Moodle announcement from me today, right? About the exam room. So there are A, B, and C. Make sure you go to the correct room. So you're lucky. Burton, your previous instructor, he will be here on Sunday to help us invigilate. And Peter, our chair, he will also be here to help us invigilate. But anyway, we just want to make sure everything is run smoothly. Let me just go back there. Okay. Okay, written questions. Okay, guys, please. Okay, written questions. Again, if there's any written question, that should be less than 10% of your exam. As I said, it would be the minimum, okay, if there's any. One question could be like this. I will simply give you, for example, integer get Fibonacci sequence, the first one, let's say the first I numbers of the Fibonacci sequence. I'll simply give you this. And then your task, implement it. Okay, how about this? The best way for you to practice for the written question, there are two things you can do. Number one, you can look at the practice question for lab test 2. Okay. Number 2, you can also look into the practice test for lab test 3 about a coffee shop. Okay. Again, as I said, if there's any written question there, it wouldn't be difficult. Okay. Any other questions? Yes.
Is the format for questions like it's going to be like how it was for lab test 2?
Very similar. Yes. If I will definitely make sure it's clear to you.
Like
yeah.
the things have been like initialized now.
Yeah, exactly. Yeah, something like that.
We just have to do
Yeah.
that.
Yeah. Correct. Yeah. Okay, any other questions? Yes?
So, for example, this question, once you have string variation, will you be sure about how specific our code is?
Yeah, so good question. Let's say, of course, if you're given a question like this, you have to, well, typically, up to this point, the question may involve if statements, involve loops, etc. Your best advice would be you may want to sketch the idea a little bit about what cases you want to have for this particular solution, and sketch the solution on the paper, and then put the solution on the actual answer box. Because when the TA actually reads your, if the TA has to read your answer, they're simply going to compare that against maybe a certain solution. But if your answer is not exactly the same, that's okay. The TA might, based on the experience, they can judge to see if that's correct or not. Okay.
Like how specific is it? Because like if you do like a for loop and you forget like to write instead of like in time,
Yeah.
it's time,
Yeah.
it won't run.
Yeah. So I would say if there's any programming question like this for the writing, it wouldn't be as stringent as the lab test. In a lab test, we do have a compiler or Eclipse to help you. So in that case, it's fair game. You do have the warning from the Eclipse. But in the exam, as long as it's not too ridiculous, right, then you'll be okay. What can be ridiculous? If you simply write in English how the solution should look like, no Java, nothing we can do, right? Yeah. Huh? Yeah, we'll definitely give you expected output. So if we give you this question over here, we'll tell you that, for example, if you try to say get Fibonacci sequence, if you say 0 over here, it's going to give you empty array, right? And then we'll say if you got, for example, 2, it's going to give you 1, 1. You know, stuff like that. Yeah, we'll make sure it's clear. Wow, you're really pushing. If there are any written question there, maybe between 2 and 3. I really expect you to spend most of the time in the multiple choice, not really written. As I said, we got 430 papers to grade, so I will be nice to my TA, right? Yeah. All right, I'll take one by one. Yes. Guys, okay, please, you know. I can go over aliasing, okay? Let me talk about aliasing quickly, okay? Okay. Okay, about aliasing. Aliasing, in a general sense, it simply means if you have certain objects that you draw over here, right? If there are multiple arrows pointing to the same objects, that's aliasing, okay? So now, yeah, what else should I say? How can you have aliasing? For example, if you got person over here, again, person P1 is something, okay? And also person P2 is something over here, right? So that means you got P1 pointing to some person objects, and also P2 pointing to some person objects, right? So now what's really aliasing? At the moment, we don't have any aliasing because P1 and P2, they point to different objects, right? So if you simply try P1 equals P2, it's going to be false. There's no aliasing at the moment. How can you have aliasing? You've got aliasing where you start to copy addresses, okay? For example, if I try P1 equals P2, oh, sorry, let me say it again. How about this? Let's do a little bit different exercise here. What's going to be the difference between if I say, number 1, P1 is assigned to P2, versus if I say P2 is assigned to P1? It means something completely different, of course, right? But you want to be very clear during the exam. Don't confuse yourself. If you do it the other way, everything else will be wrong, okay? So now, the principle is very easy. The principle simply says the following. You are going to change the left-hand side. Only the left-hand side is going to be changed, okay? The right-hand side is going to be copied to the left-hand side, okay? Let's apply this principle. If you say, number 1, if I do that, that means P1 is going to be changed, So that means this arrow is going to be invalid. Okay? And then it's going to now become whatever arrow that's pointing to by P2. In that case, P1 is simply just going to point to P2, right? Wherever P2 is pointing to. That's scenario number 1. Let me undo this. What if I try the second one? If I say P2 is assigned to P1, okay? I'm changing P2. That means I'm not going to point there anymore. Now, where is it going to point to? Wherever P1 is pointing to. So that means P2 is now going to point to here. That's the second scenario. Okay, completely different. Aliasing, the best way for you to answer question during the exam is by drawing diagrams. That's why I keep emphasizing diagrams. Okay.
Can you go over like questions like 1 and 2 on quiz 3?
Quiz 3?
Yeah.
Do you have AirDrop? You want to drop it to me? Yeah. Thank you. Which one?
1 and 2.
1 and 2. Sure. Okay, so now I'm going back to the good notes. One and 2. Okay. So now let's try this. So number 1, I'll make it bigger. Okay, when executing the following fragment of Java code, how many times will the state condition, which is here, state condition is over here, okay, this is I less than 49, of the loop be evaluated? Okay, this question here, how many times is it going to be evaluated? I even give you hints, either to true or false, right? Remember the pattern of a normal loop is this particular state condition over here is going to be true for the first time. If that's true, you can go into the loop. And then it might remain true for a few times until once you get to false, you exit from the loop. That's kind of the pattern, okay? So what about in this case over here? If you look at that, I is initially minus 49, okay? So now, what about I less than 49? Minus 49 less than 49 will be true. So that means we go into loop for the first time. And then every time at the end of the loop, you're going to say plus plus, okay? The only tricky things over here. Minus 49, minus 48, and all the way to minus 1, right? 0, 1, all the way to 48. Up to now, I less than 49 will still be true, agree? As soon as we get to 49, it'll become false, right? Everything over here is still true. So now, let's count. How many times? Can you see? Minus 49 until minus 1, we got 49 numbers. And 1 until 49, we got 49 numbers. And then here, got 1, 99. Maybe you forgot to count the 0 case, maybe. Yeah. That's why. Right? Maybe you forgot to count 0 as well, right? Now solve the puzzle, right? All right, number 2. Number 2 is basically very similar. Okay, basically the same question, except we are basically asking how many times will the body of the loop is over here. How many times will it be executed? Basically, the number of times you're going to execute the body of the loop correspond to how many times the state condition evaluate to true, right? How many times? Well, exactly 98, right? Because the final time is actually when you evaluate to false, so that's why 98. Okay. How to assign values to an array? What specifically? What do you mean?
Like the question we just did, like
Example
example number 6.
number.
Test for using rules.
Oh, are you talking about exam questions or? Okay, how about this? If you can tell me exactly the syntax you're talking about. You mean to declare an array or to assign to an array? So for example, if I got integer a, and then you're talking about this notation here. So okay, so if I got, oh, let's say P1 and P2, sure. Okay. Yeah, I want to make sure, otherwise I'm repeating something you already understand, right? I don't need to. Person array, and let's say PS, is assigned to, let's say, P1 and P2. Is that what you're talking about? Okay. How about this? Before we talk about this example over here, let's talk about another easier one. If I got integer array, let's say is, okay, integer array, integers. Let's say integer I is assigned to 23, integer j is assigned to 46. And then I simply put I and j over here. Okay, similar idea. First of all, how do you visualize that? You want to know how many elements am I trying to initialize is into. Is is pointing to some array, but because I got I and j, 2 elements, right? So for this part, it's easy, just an array of size 2. And then in the following order, I first, followed by j. So I will be at position 0, j will be at position 1. Okay. So now what's the value for I? 23. What's the value for j? 46. Okay. When we move to reference type, it's just the same idea, just the same. How? Let's say at the moment we got P1 and P2. Let's say again P1 is pointing to this particular object, and P2 is pointing to this particular object. Let's say orange versus pink. Okay. So now if I do this one here, first of all, what should be the size for PS? 2. Okay. I will put it here. Okay. PS is going to point to an array of size 2, 0 and 1. Okay. And now we know that we're going to put P1 into position 0 and put P2 into position 1. Okay. Now what do I really mean by put into, right? For example, I'm going to say PS at position 0 is going to be assigned to the value for P1, right? For that one there, that means we are changing the value for this. We are not changing the value for P1. So P1 is currently pointing to this particular object. So after this, PS0 is going to point to the same object like this. Okay? Similarly, after that, P2 is going to be stored in the position 1. In that case, it's going to point to just the same objects as here. Okay? Make sense? Okay. Null pointer exception. Yes. You mean to explain the idea in general, or okay? Null pointer exception. Let's give some idea over here. Okay. Null pointer exception. The idea is very simple. Whenever, let me talk this together with array index out of bound exception. Okay. Okay, exception. Okay. So now think about the syntax that can cause you array index out of bound exception and also null pointer exception. Whenever you have the following syntax, let's say some objects dot some method. This is how there's a possibility you might run into null pointer exception. Whenever you have some array, some square brackets, and then some integer over here, this is how you can run into array index out of bound exception. Okay, just don't worry about the syntax. Okay, so now let's try this. Okay, let's say I got, let's say, person objects. Person PS is assigned to, let's say, new person. Let's say 3. Okay, so now let's think about it. Now if I try PS at position 0, I know it's a person, right? Dot get name. Let's assume there's a get name accessor in the person class. So now is this going to work? you have to visualize the array over here. So PS is pointing to a new array over here of size 3. Okay, 0, 1, and 2. As we talk about in the class, you can check in the classes of default values. For reference type, if you have not explicitly initialized the elements, it should be null, right? So that means in the beginning, every one of them is simply just going to be null. Just like that, right? Null simply means it stores no address, okay? Now, if I try PS at position 0 over here, it's to the left of the dot. So this I know at the moment is simply just null, right? So now, if I say dot simply means I want to go to this particular memory location to the object and then try to call this particular method. But it wouldn't work because there's no such memory location in the memory, right? So that's where you get null pointer exception. Okay, so every time when you have the dot notation over here, you have to worry about whether the left-hand side, the context object, again, okay, you really have to understand what context object is. If the context object simply store no meaningful address, specifically null, then that will be bad. Okay, let me just remind you one more time, okay, about the programming pattern. Let's say we got a point collector. Let me just write it properly. Okay, we got a class point collector. Okay, so now we got points array PS, and also we got let's say integer number of points, number NOP. Okay, that's something you should be very familiar already, right? I assume. And let's say we have the following. Let's say we have this void add points. And then I have point over here, P. Okay, let me just do that. PS at position NOP is assigned to P, and also NOP plus plus, right? Standard, okay? By the way, you don't want to memorize this because in the exam, I might just modify the code a little bit to see if you can still trace it, okay? So now let's try, what I want to go over again with you is this, just to review null pointer exception. Let's say I want to print out all the points. Let's say I'll just say, okay, let me just do a better style. String get description. Okay, like that. I want to print out all the points. So how do I do that? I can simply do, let's say I run a loop for integer I is assigned to 0, I less than PS dot length, and then I plus plus. Okay, let's say string S is simply just empty string to begin with. And then I can say S plus equal, let me put this, let's say PS at position I dot X. Let's get X, how about that? Let's assume we do have to get X. Okay, and plus some comma over here, plus PS at position I dot get Y. Okay, and then after this, we're going to return S. Okay, so far so good? Okay, is there anything wrong with the code? Okay, yes, can you tell me which one that's wrong? The state condition, okay? For those of you who know, good for you. If you haven't noticed the error, you should really study for that, okay? There's something wrong with the state condition over here, okay? Let's just see why quickly. Let me just do one more, just make everything complete for you. Let's say we also got a point collector constructor. Okay, I'll simply say PS is assigned to new points. Let's say it will simply just be 5, okay? Let's say. Okay, that's about the point collector class. Let's say we have a tester. Okay, so what I would do is I'm simply just going to have a tester over here. Okay, write some code. So I would say point collector PC is assigned to a new point collector. You can do that, right? So what is it going to look like in the runtime? PC is going to point to a point collector, right? Whereas the default value for, so now we're going to call the constructor over here. We're going to call that, right? And then NOP will just be default value 0. No point have been stored. What about initializing this array to be size 5? That means the PS is simply just going to point to an array of size 5. Okay? 0, 1, 2, 3, 4. All of them are going to just point to null. Agree? Just point nowhere. Okay, every one of them. Okay, let's try this. If I do PC dot, let me just add 1. Add points. Of course, I can say point P1 is new point, let's say 3 and 4. And then add point P1. Okay, executing these two lines are very easy. I'll just do it. Okay, I'm going to create this particular points for P1. And then it's going to be x and y, 3 and 4, right? So now, after adding this point, so now position 0 is now going to point to that particular point objects, right? Okay, we're getting there. Now, let's consider this method call. If I try PC dot get description, now, what's going to happen? If I say PC.get description, well, that means I'm going to call this particular method over here, right, for PC. And PC looks like this at the moment. I can tell you exactly what's going on, okay? If you have doubts, you can definitely refer back to the tutorial video. I just want to review very quickly. The answer is you're going to get null pointer exception. But now, let's be more precise. Exactly where? Okay, this is exactly where you will get null pointer exception. Okay, but now let's be even more precise. Which iteration? Okay, second iteration. Okay, very good. Okay, so now in the second iteration for the loop. Okay, now in the second, I'll write it properly. In the second iteration of the loop, we know that I is just going to be 1, right? So now that means we got PS at position 1. But PS at position 1 is simply just null. Null.getX will just give you null pointer exception. Okay? Null pointer exception. So you want to be 100% sure, number 1, there will be a null pointer exception. Number 2, where exactly? And number 3, which iteration? Okay? And one more thing. How do we fix it? Yep, exactly. Thank you. For this, I'll consider this basic for exam. Okay? There will be some variance to this during the exam. Yes? Oh, in this case, yes. Okay. Basically, you're talking about the use of this, right? Okay. You're right. In this particular case, you can see there's no input parameter over here, so there's no possibility of ambiguity. So if you simply say NOP, that's absolutely fine. Okay? The reason that I use this, there are 2 reasons. Number 1, just make it easier to replace the context objects. Number 2, when there are some ambiguity for input parameter and also the attributes, it's easier to use this. Okay? But for this case, no. You can just use without this. Okay, any other questions? How many of you will be taking 2030 in the fall? How many? Well, too bad. You'll be taking with Burton. Either good or bad, I don't know. Yeah, I don't know. Very different teaching style. But guys, if you take 2030 in the fall, make me proud. Make me proud by performing well, right? All right. But by the way, as I promised, since we got very high evaluation response rate, 2%. Okay. Huh? Okay. I tell you what I will do for the exam. After the exam, I'm gonna calculate your row marks. Basically, out of 100, that's something I will see first. You know, I got a spreadsheets, and then I'm actually going to see. First of all, I'll see without the 2% addition, I'll calculate, and then I'll add a 2% for everybody. Okay, hopefully that will make you close enough to the next cutoff points. That's my hope. Okay, but for the exam, you only got, well, you want to take some break. You don't want to spend all your Saturday, you know, studying for this course. This is my final advice. Okay, you want to really focus more on the OOP. Okay, especially make sure you understand very well two things. Number one, make sure you understand very well the point and point collector example. Okay. Number two, make sure you understand very well static. Okay. But studying my slides and make sure you understand exactly what the example is, that should be sufficient. And now, let me say one more thing. I always got students coming to me. They say, I spent so many hours studying for the slides, but still cannot perform very well. So my response would be, maybe when you study, you don't want to be too passive. You really want to see exactly what's the logic for the example. You don't want to read through the code. You want to think about what's going on. And make some changes yourself to the code and see what's going on. Right? You want to play with the example. Okay, are we good? Okay, I'll see you on Sunday. Okay.